2 times 1, I get 2. If I do 5 times 1, you get 5, you get the number back. So the identity element is the 1 for multiplication. When we talk about matrices, we have something that we could multiply to another matrix that will give that matrix right back, just like 2 times 1 gives us 2 back. And 5 times 1 gives you 5 back. It's a square matrix that when multiplied by another one equals that same matrix. Here's the identity element, or identity matrix, is when there are 1s down the main diagonal. And we'll just do the 2 by 2 for now. And 0s every place else. If I take any matrix that's a 2 by 2 and multiply it by this one, it'll give me that matrix back. Matrix. And again, on the right-hand side, I'm going to try to connect it to something that you already know about and try to connect it to how it would look as a matrix. Multiplicative inverses. What would we need to multiply 3 by in order to get the identity elements? Brenner? 1/3. Okay. If we had -2, what would we need to multiply to get 1? -1/2. That would give me 1. It gives me the identity element. Okay? So when we look at matrices, if we multiply 2 matrices together and the answer becomes the identity, we would know that they're inverses. They undo one another. So if we had some matrix, and I'm just going to write this in. And this produced the identity matrix, we would know for sure that these matrices undo each other. They provide us with the identity matrix. They undo each other. We're going to do some examples. Fractions and things like that. So we're going to use our calculators to show whether or not these are inverses. If you try to do this by hand, you're going to be spending lots and lots of time just doing arithmetic, and you could make a mistake. Right? So we're going to bring out our calculator, and we're going to clear it out. And we're going to put that first matrix in the calculator. So we're going to go second, the x -1 button, go over to edit, and we're going to type in our A matrix. And it was a 2 by 2. Oh, not 22. Goodness gracious. It's having problems. Yeah, let me fix it here. There, that looks a little better. 2 by 2. And we're going to multiply them, So you might need help putting it in the second x-1 -1 button. edit, go down to B, and it was a 2 by 2. Now the cool thing about this is when you put in fractions in the calculator, it will automatically change it to a decimal for you. So if we want to put in 1/2, so I hit 1 divided by 2 and hit enter, it'll change it to 0.5 for you. So if you get some crazy fraction that you don't know what the decimal is, it'll do it for you. And 1/4. Come on, calculator. Pick up your matrices. A times matrix B. And then you hit enter, and we're looking for, did we get the identity? No, so these are not inverses. Who asked me how did I get that? Are you good?
All right.
Second mode. Okay, and then second x negative 1. Now, guys, ladies and gentlemen, listen please. Listen please. It is possible that these matrices are something larger. Okay, it could be that this one has 3 rows and 2 columns, and this has 2 rows and 5 columns or something. As long as it, then that means that this matrix, this identity, the ones, there will be more 1s and 0s. The 1s need to be down the main diagonal, which means from the upper left to the bottom right, and 0s every place else. All right, somebody had a question. Something larger, and we will look at that later, and that's all calculator. But for a 2 by 2, the inverse of a matrix, and you have elements A, B, C, D, there's like a little formula to find the inverse. And this little -1, this little -1 above the A, that stands for the inverse of A. Okay. And I'll do an example and show you how to do that. So write down the little formula. The first step is to find the determinant. That is what this part of the formula is. This is the determinant, where we multiply down the diagonal for Monday. -1 times -2 is 2. 8 times 0, 0. What's bottom minus top? 2, right? Step 2 is to put it in the formula. So we're going to have 1 over the determinant. I'll give you a minute to write it down. And then it's just a matter of switching some numbers around. See how A and D are in the main diagonal? See how they got switched? So these two switch places. These two become the opposite sign. Now we can't have the opposite of 0, so we're going to leave it. And now you can multiply through. Sometimes on a multiple choice, it will be left as this. Sometimes on a multiple choice, they will go ahead and multiply this through. What's 1/2 times -2? -1. 1/2 times 0, well that's 0. 1/2 times -8. 1/2 times -1. So this would be our inverse matrix. If we took our problem, our original, and our answer and multiply them together, it'll give us all those 1s and 0s. Now, it all depends upon what the determinant was. If the determinant was 5, we'd have to multiply by 1 over 5.
What is It's all the same.